In this unit, we will learn about the Wireshark tool that allows us to view and inspect messages, aka packets, that are passed through a network. Using the Wireshark tool, a free tool you can download from the web, we can see the communication in a different way. We can look at the packets and analyze their structure. The packets are sent and enter our computer using the network interface we are connected through. Wireshark presents the activity of the computer's network interfaces. The tool presents the set of network interface cards, NIC, in our computer, and those of them that are sending and receiving messages. To see the packets of a specific network interface, we'll choose the desired interface of an interface list. It's clear that if we select the wrong interface, we can encounter a problem and won't see any packets. In our case, the correct interface is the Ethernet interface, so that's what we'll select. Now, this looks a bit messy. Let's go over it step by step. Let's look at the tool's main window. The window shows all the messages, packets coming in and out of the NIC. Every line here is a sent or received packet, where for every packet, we show a set of parameters in this window. In this video, we'll present the default line. For the sake of example, we can see the packet number since beginning of capturing, time relative to capturing, origin and destination address. In our case, we'll expect to see destination and source addresses, the packet protocol, packet length, and other data about it. If we click on a specific packet and look at the screen under the packets, we can see that the screen changes and shows all the packet details, all the data the protocol used, additional data the tool calculates or presents that isn't in the protocol title. How do we differentiate if the value is between two square brackets? This is what Wireshark adds. Please note that sometimes we'll also have a mix of protocols, and we'll see examples for it in the future. Below, we can see the packet presented hexadecimally in the picture on the left, and on the right in ASCII. Because this is a representation for each click on a parameter, we'll see where it is both in the ASCII part and the hexa part. One of the important options in this tool is the display filter, which allows us to filter interesting packets using known operators, and or, greater than, less than, etc. On a confusing screen loaded with information, the filtering allows displaying information conveniently, focused on what we need. How should we filter? In the first stage, we can just write at the top the name of the protocol which we want to filter messages from. Now let's look at something interesting. Let's look at HTTP packets and filter by TCP. If we want to filter a specific field, there are a few ways to do that. One possibility is to click on a specific packet. We'll go down to the Packet Details window and click the protocol and a specific field. In our example, we'll click on the source IP address. Note that the moment we click this and it says ip.src at the bottom left, meaning this is the field the tool uses. If I copy it into the filter on top to look for an address, we can find all the packets with an address of source equal to the address we put into the filter line. If I want all the packets leaving or coming into or from that address, I will use ip.addr. Another option is to right-click the field and ask the tool to filter. We can implement a complicated filter clicking on the cursor and adding the filter, and if we want to see the options, and click Analyze Display Filter, and then we can look for the field under the protocol as well as select operators we want to use. What else can we see using the tool? In the information statistics, we can get data on the packet sizes, on the number of conversations, and in the conversations themselves, we can see whom we're talking to and get data on the conversation itself. Let's filter like that. For example, note that ip.iddr gives us an option to ask for filtering by address, regardless of whether it's a source or destination. This is an option to make this simpler. By marking the streaming tcp.stream, the Wireshark allows us to save the entire capturing, or only part of the packets in the file. When we want to run the capturing, we can upload it, and when we want to re-record, we can click Restart. Now you. Download Wireshark, look around at the many options until you get to know them, and can derive information from them. And another important point, when you surf to websites, notice whether the site works on HTTP or HTTPS protocol. In other words, whether it encrypts information or not. Some of the browsers show that with a lock symbol. Why is it important? Because if it's encrypted, don't expect to see the overt HTTP headline displayed overtly in Wireshark. Good luck to you!